Hello students, so we'll discuss a few questions related to the chapter Haloalkanes and Haloarenes. Okay, so in the first question what you can see is a molecule with a double bond to it, and HBr is you add HBr. So basically it is an addition reaction. Okay, so this molecule reacts with HBr. So how will the reaction proceed? So this is based on Markovnikov's rule. Hydrogen adds to carbon with more hydrogen atoms. Okay, so here in HBr, this hydrogen will be added to the carbon having more number of hydrogen atoms. Okay, so here this carbon, the carbon which I numbered as 1, it has 2 hydrogen atoms. Okay, whereas in this carbon which I numbered as 2, it has only 1 hydrogen atom. So basically, as per Markovnikov's rule, the hydrogen will be added to the carbon with more number of hydrogen atoms. So basically, this H will come in this position and Br will come in the second position. Okay, the other way is you can just break the double bond as plus and minus. See, if you just break the bond, it will be like here you get a plus and here you get a minus. Okay, and here you get C6H5, and here you have hydrogen, and here you have hydrogen and hydrogen. Okay, so the reason that I broke here as plus and the other side is minus, you can either do minus and plus, that is also an option. But basically it is based on concept that carbocations, basically when you look at the stability of carbocation, tertiary more stable, then secondary, then primary. So when you place this positive charge at this position, it will become a secondary carbocation. So that is the reason I gave plus over in the second position. Okay, so if you break this bond as here plus and minus, what happens? You can write here this HBr as H plus and Br minus. Okay, so Br minus will be going to the carbon having a positive charge. So basically Br minus will be coming to this position, Br minus will come in this position, and H plus will be coming in this position. Okay, so if you have a confusion Markovnikov's rule, you can also do it in this way. Basically you can break the bond and give it as positive and negative, and the thing that you have to notice is that you have to place positive charge on the carbon. Like if there is a secondary, you have to break in such a way that it becomes a tertiary carbocation or secondary carbocation. Okay, so in this case there were two options. Either you can break the bond by making it as secondary carbocation, or by breaking it to give a primary carbocation, and we know that secondary is more stable. So that is the reason we broke the bond in such a way that the carbocation is secondary. Okay, because secondary is more stable. So you break the bond and see that when you break the bond, you just have to ensure that the carbocation is more stable. So in that case, we made this as positive and this as negative. Okay, since secondary carbocation will be more stable. Okay, that's the reason we broke the double bond in this manner. Okay, now you can just do the reaction. Basically, hydrogen will be added to the carbon with more number of hydrogen atoms. Okay, so when you break the bond also it was the same. Okay, Br minus will be going to the carbon having a positive charge. So Br minus will be coming to this carbon, and H plus will be going to the carbon having negative charge. Okay, so this is also in this way the reaction will proceed. Then next look at the second reaction. Okay, this is also based on the Markovnikov's rule. Here you have a double bond and then you are adding a hydrogen halide. So here how it will be like H plus and Cl minus. Okay, H plus and Cl minus. So here you can break it in such a way that this gets a positive charge or this carbon getting a positive charge. I told you carbon having, you have to look at the carbocation stability. So when you break the bond, make sure of that case. So here you can break the bond as CH3, CH2, CH, CH2. Here you will be getting a positive. Basically you are breaking this bond, okay, this pi bond, and here you get as negative. See, other way, how can you break it in the other way? It will be like CH3, CH2, CH, CH2 plus and minus. See, this is the two ways of breaking this bond. Okay, either you can give this carbon as positive or you can give as negative. And what I told you, like positive carbocation in like when it is in the secondary position, that is more stable. Secondary carbocation is more stable. So you will go with this structure. Okay. So you don't go with this structure, you go with this structure. So in this case, again here H plus and Cl minus. So basically Cl minus will be coming to this carbon and H plus will be coming to this carbon. So again this is also following Markovnikov's rule. Basically what the hydrogen will be added to carbon having more number of hydrogen atoms. So this hydrogen, this double bond will break and you get this hydrogen over here and Cl over here. So you write it as okay. Now the third question. Here also you can see a double bond and here hydrogen bromide, then peroxide. When you get peroxide, it becomes the opposite of Markovnikov's rule. So it is anti-Markovnikov's rule. Basically, in the previous case, what we saw was an alkene reacting with a hydrogen alkene reacting with a hydrogen halide. So when an alkene reacts with an hydrogen halide, it will be following the Markovnikov's rule, the general, which we discussed in the previous two examples. But in this case, when this peroxide, it will follow anti-Markovnikov's rule, basically the opposite of Markovnikov's rule. So earlier what we said, like hydrogen will be added to carbon having more number of hydrogen atoms, right? So now hydrogen will be, but as per anti-Markovnikov's rule, it is just opposite of Markovnikov's rule. So hydrogen will be added to carbon having less number of hydrogen atoms. Okay. So here also you can break. So when you break, it be like here you get a positive charge. Here you get a positive and here you get negative, right? And then the other molecules. So here it will be like H plus Br minus. Okay. So what do if peroxide was not present, what would happen? Like Br minus will come in this position and hydrogen in this position. But I told you it is anti-Markovnikov's rule. It is the opposite of Markovnikov's rule because peroxide is present. So you need to see in the question if peroxide is present or not. If peroxide is present with hydrogen halide, then it will proceed with anti-Markovnikov's rule. Okay. So here you write it as so here Br minus will be we will be thinking like it will be going to this position, but no, it will be coming in this position. So it will be like Br. Okay, and then the next reaction. Okay, here to the cyclohexane you can see an OH attached, then SOCl2. SOCl2 is basically thionyl chloride. So this example is an example of how to prepare alkyl halides. Okay, basically what happens is that OH will be replaced by Cl. Okay, OH will be replaced by Cl, and this we have studied in the preparation, like how to prepare haloalkanes. So in that you can see this method, that is you react with ROH with SOCl2, you get an alkyl halide. Okay, so here this OH will be replaced by Cl. And then it releases SO2 and HCl. Okay. Then moving on to the next reaction. So here you have, this is actually this molecule, it reacts with bromine and you give heat and UV light. So this follows free radical mechanism. Okay. So you incorporate this Br2 in this position. CH2 attach just Br. So in this case, this hydrogen will be replaced by bromine. Okay. And then next case, here you can see that, you see in the next 6th question, you can see that there are 2 OH groups. Okay. And you have HCl. So basically which OH will be replaced? Basically this OH will be replaced with Cl. Okay. When you heat it. And then the next question, that is, this is also an alkene. See, alkene is basically a compound having a double bond. Okay, so here you have an alkene and you react with hydrogen halide. Okay, hydrogen iodide. Here you don't have peroxide, so it will be following Markovnikov's rule. Okay, so here you can see that 1, 2, 3, you have one hydrogen, 1, 2, 3, 4, no hydrogen. So hydrogen will be added to carbon having more number of hydrogen atoms. So here this carbon is having more number of hydrogen atoms. So basically this hydrogen, 1, 2, 3, 4, 1, 2, 3, 4. So basically this hydrogen will be added to this carbon. Okay, and iodine will be added to this carbon. See, basically it will exist as H plus and I minus. It means H plus and I minus. Okay. Then comes the next question. Here what you have is here you have like bromine, alkyl bromide. Okay, alkyl bromide and NaI. And here you have a reagent like triacetone. This is actually a Finkelstein reaction. Okay, basically for the preparation of alkyl halides you do all these methods. All these methods are present. So in this what you have is this Br will be replaced by iodine. Okay, so this is the Finkelstein reaction. So basically you will have to learn all these reactions and learn them. Okay, you don't know like in exam what questions will be asked. So basically you need to know all these questions. Okay. Then this question, that is alkene bromine. Okay, this is also basically like Friedel-Crafts. You have UV light. Okay, Friedel-Crafts reaction. So here what happens is that this bromine will be added to the alpha carbon. Basically this is alpha. If you have this is a functional group. The functional group can be anything. Okay, so here the functional group is alkene, double bond. Double bond is a functional group. Okay, so the functional group can be COH, OH, anything like. So here the functional group is double bond. So alpha carbon, this will be the alpha carbon. This is an alpha carbon, this is also an alpha carbon. So carbon to which this functional group is attached. Okay. So the adjacent carbon to which the functional group is attached. And then this is the beta carbon. Okay. So basically bromine will be attached to the alpha carbon. Okay. Okay, so I hope this is clear. We'll discuss a few more questions. So here you have arranged based on boiling point. Okay, so here you have a set of compounds. So you need to arrange them based on the boiling point. Okay, so here what bromomethane. So here you can see that the name of the compounds are given. So first you need to identify the compound, identify the molecule based on the name. So that is important. Okay, at times if you say like phenol, you need to know what is phenol, right? Only then you will be able to answer the question. So first you need to identify the compound. So in this case you have been given a set of compounds. So you need to identify them first. So here bromomethane. Methane, you have one carbon atom, right? So bromomethane, bromine is attached. So CH3Br. Okay. And then bromoform. In bromoform, you have basically it has the structure CHBr3. Like in chloroform, you have CHCl3. Bromoform, CHBr3. You need to know, like when someone asks the compound name, you must know that okay, this compound is this. You must be knowing that. So if you don't know what is bromoform, you won't be able to solve this question. Okay. So you need to know. You need to identify the molecules based on the names. Okay, which is important. Then comes chloromethane. So methane, one carbon atom, chlorine atom. So CH3Cl. Okay. Dibromometane. Basically, methane. You know what is methane? Methane is actually a carbon atom. Methane basically basically will have one carbon atom, then 4 hydrogens attached. So basically CH4. Basically methane is CH4. Okay. When you say methane, basically you will have by the word that you know that you have one carbon atom, and then you know the valency of carbon is 4. So you attach 4 hydrogen atoms. So when you say methane, it is CH4. Okay. So when you say bromomethane, what does it mean? Like, you need to first think, okay, methane, it is CH4. Bromomethane, so basically you replace one hydrogen with the bromine atom. So you replace one hydrogen with bromine, so it becomes CH3Br. Okay. Then bromoform. So you need to remember bromoform is basically CH3Br3. Okay, only then you can solve the question. Then chloromethane. So basically, you know, methane CH4, you replace one hydrogen with chlorine. So CH3Cl. Then dibromomethane. So dibromomethane. So basically, there are 2 bromine atoms. So you replace 2 hydrogen atoms with 2 bromine. Okay, so that is why CH2Br2. Okay, you replace 2 hydrogen atoms with 2 bromine. So dibromomethane. So CH2Br2 is a structure. Okay, so now we have to we need to arrange these set of compounds, these set of molecules based on their boiling point. So basically, the intermolecular interaction. Basically, when we say about boiling point, the intermolecular interactions between the molecules, it will be determining boiling point. Okay, you have van der Waals force, hydrogen bonding, dipole-dipole interactions, all these. So in order to solve this question, what you need to see is, you can see that there is difference in the halogen atom, right? Either it is bromine or it is chlorine, and either you have one halogen atom, 2 halogen atom, or 3 halogen atom, depends. So when you look at the question, that is the difference that you see. Basically, it is the difference in the number of halogen atom and the type of the halogen atom. Okay, so how do you solve this question? So what you need to notice is that, what you need to remember is that molecular mass is directly proportional to boiling point. Basically, if a compound, if a molecule has higher molecular mass, it will be having a higher boiling point. Okay, higher molecular mass, higher boiling point, you can write it. It is directly proportional. So if a molecule has higher molecular mass, it will be having higher boiling point. So in this case, the halogen atoms, you know, bromine, here you have 1 bromine, 3 bromine atoms, 1 chlorine atom, 2 bromine atoms. So here the difference is the number and the type of the halogen atom present. And you know that halogen atom, basically it has a greater size compared to carbon. Basically halogen atom, here bromine and chlorine. So it has a greater size compared to carbon atom. Okay. You know, as you move down the period, as you move, like when you go across a period and across a group, how it changes. You must be knowing the size, how the size varies. Okay, so basically bromine and chlorine will be having a greater size compared to carbon atom. Okay, so here, and you know, chlorine, bromine is present below chlorine, like, you know, fluorine, chlorine, bromine, iodine. So basically iodine will be having a higher, greater size compared to bromine. Then, so fluorine, among fluorine, bromine, iodine, fluorine is having a smaller size. So when you compare chlorine and bromine, what you need to remember is that bromine has a higher size compared to chlorine. Okay, so basically bromine will be having a higher molecular mass. Okay, so in the first case, you can keep this. Okay, so this CH3Cl will be having a lower boiling point. Okay, now among these three, since CH3 has 3 bromine atoms, it will be having a higher molecular mass. So if it has higher molecular mass, it will have higher boiling point. Okay, then you have another compound with 2 bromine atoms. So since there are 2 bromine atoms, it will be having also higher molecular mass, but less than that of CH3. Okay, so this will be having a greater boiling point compared with the rest. And then this. So how do you arrange them? So first, this has a higher boiling point. So when you write it based on boiling point, this has a higher boiling point, then 2 bromine atoms. So CH2, Br2. Then 1 bromine atom, CH3, Br, then CH3. So this is the boiling point order. So Br3 has a higher boiling point, then comes CH2, Br2, CH3, Br, CH3Cl. So bromoform, dibromomethane, bromomethane, chloromethane. Okay, this is the order. And next you have other set of compounds. One chloropropane, isopropyl chloride, and 1 chlorobutane. So 1 chloropropane, you know the structure of propane, right? Propane, so it will be having 3 carbon atoms, right? So actually propane is basically CH3, CH2, CH3. Okay, I hope you know that. Basically propane is CH3, CH2, CH3, prop 3 carbon atoms. So CH3, CH2, CH3. So that is propane. So one chloropropane is basically one hydrogen atom will be replaced by chlorine atom in the first position. So when you number it as 1, 2, 3, 3 carbon atoms in the first position, this hydrogen, one of the hydrogen atom will be replaced by chlorine. So that is one chloropropane. So here when you number 1, 2, 3, in the first position you remove one hydrogen atom and you replace with chlorine. So that is one chloropropane. Then comes isopropyl chloride. Isopropyl chloride, again propyl, so that means it will be having 3 carbon atoms. So here you can see 1, 2, 3. But here there is iso. So basically 2 groups will be similar. So CH3 and CH3. Okay. So that is why isopropyl chloride, propyl, you have 3 carbon atoms. Isopropyl group is this. CH3, CH3. This is the isopropyl group. Okay. So you have 2 CH3s similar. Okay. CH3 and CH3. So it is, so that is why you call it as isopropyl. Okay. So isopropyl chloride. So you also have to remember the structure of isopropyl chloride. Only then you will be able to solve this question. Okay. Then one chlorobutane. So basically butane, you know, 4 carbon atoms. So it will be like CH3, CH2, CH2, CH3. Right. So again in the first position you replace, if you number it as 1, 2, 3, 4. 1, 2, 3, 4. You replace chlorine in the first position. You replace one hydrogen atom in the first position with chlorine. Okay. So that is one chlorobutane. So now you got the structure of these molecules. Now the question, you need to arrange them based on the boiling point. Okay. So here what is the difference? Here you can see that here you have 3 carbon atoms, here also you have 3 carbon atoms, and here you have 4 carbon atoms. And this is a straight chain. Basically when you have a straight chain, it will be having a higher boiling point. Okay. When compared to, so you have to compare this and this. Okay. One thing you need to remember is that if you have a higher molecular mass, you will be having higher boiling point. Okay. Then you have straight chain and branching. If there is a straight chain, comparatively that straight chain molecule will be having higher boiling point. Okay. So in this case, this is a branched one. So you keep this aside. So when you compare these two will be having higher boiling point compared to this. Okay. And you compare these two, it has 4 carbon atoms. So basically it will be having higher molecular mass. Okay. So basically this will be having highest boiling point among these 3. And then this will be having the second highest boiling point, and the third, the least one, will, the lowest boiling point will be for this compound, isopropyl chloride. Okay. What is the reason? Basically when you have branching, what happens is that boiling point decreases. So here you can see that these two compounds, basically the molecular mass is same. You can see that like both the compounds have 3 carbon atoms and 7 hydrogens. Both the components have 7. Basically when you look at the when you write the molecular formula, it is the same, but the only difference is one has branching and one is a straight chain. Okay. So basically when you have branching, the boiling point decreases. So if you write it as like A, if this as A and this as B and this as C, how do you write it? Basically this is having higher boiling point, C, which is C, and then one chloropropane, which is A, and then B, which is isopropyl chloride. Okay. And next you need to identify chiral and achiral molecules. So in the last video I have already said like how do you identify chiral and achiral molecule. Basically you need to look at the asymmetric center. Basically if a carbon, if there is only one asymmetric center, then if there is only one carbon atom and if that carbon atom is an asymmetric carbon, then basically it will be a chiral carbon. Okay. In other cases you need to look into other conditions. Okay. So here you need to identify chiral and achiral, and I have told you chiral means it will be optically active, and if it is achiral it will be optically inactive. Okay. So we'll look at the questions. See, this is a carbon atom, and I have told you this wedge represents protruding outwards and this dash represents behind the wall. Okay. So and this both is in the plane. So here you can see that to this carbon atom 4 different groups that are attached, like hydrogen, OH, Br, CH3, all 4 different. This is basically carbon. Okay. Okay. So to this carbon atom 4 different atoms or groups are attached. So it is a asymmetric carbon atom. Okay. So since 4 different atoms or groups are attached and there is only one asymmetric center over here, right? Only one asymmetric center, so it is chiral. Okay. Then you look at the second question. Here you have HCH3, but there are 2 bromine atoms, so it is not an asymmetric center. For asymmetric center, carbon atom should have like 4 different atoms attached to it. Okay. When if it is a carbon atom, it should have 4 different atoms attached to it, and here you have 2 bromine atoms. So, so in this case, this is not chiral. So, what is the reason? Basically, it will have a plane of symmetry. You should consider plane in such a way that the plane will be passing through hydrogen and this CH3. In that case, this will be this bromine atom will be reflecting the other. So there will be a plane of symmetry. Okay. So since it has a plane of symmetry, this is achiral. Okay. So I hope you understood how I told like how you need to consider the plane. You need to consider plane in such a way that the plane should pass through this hydrogen. The plane should pass through CH bond and the plane should pass through CCH3 bond. Okay, you consider a plane such a way that the plane passes through CCH bond and CCH3 bond. Okay, so if you consider such a plane, then this CBr, this will be the mirror, like it will be reflecting this CBr. Okay, so basically you have a plane. Okay, there is a plane of symmetry, so that is the reason it is a chiral. Okay, now we look into this question. Here what you can see is, here you have a asymmetric center. To this carbon you have an OH, H, then CH3, then this group. So basically to this carbon atom, 4 different atoms or groups attached. So this is, and there is only one asymmetric center. So this is chiral. Okay. Then look at this question. Okay. Here what you can see, if you look at this question, you have hydrogen, OH. And this group is identical and this group is also identical, right? So you just have to consider or you can consider a plane. So it is not a asymmetric center. Here you have hydrogen, OH, then this group and this group is identical. So it is not a symmetric center. Okay. Again you have also a plane. Consider a plane such a way that the plane passes through this hydrogen and OH, CH bond and COH bond. So you can see that this group will be reflecting this group. Okay. So there is a plane of symmetry, okay, and it is also not an asymmetric carbon, so it is a chiral. Okay, and next look at this question. Here you have, consider this carbon atom. Okay, to this carbon atom, bromine is attached, CH3 is attached, then CH2, CH3 is attached, then hydrogen is attached. So 4 different atoms or groups attached: bromine, CH3, CH2, CH3, then hydrogen. So there is an asymmetric carbon. So this is the asymmetric carbon. Okay. So this is chiral, and there is only one asymmetric carbon. Okay. Okay. Then now let's look at this question. So in this case, you can draw this molecule CH3, CH2, CH2Br. Okay. You can draw this molecule in this form. This carbon atom, see, basically this is this carbon atom. Okay, so to this carbon atom, CH2, CH3, okay, is attached. Then CH2Br is attached. Then 2 hydrogens. Okay, so again you can consider plane such that it passes through CH2, CH3 and CH2Br. So this hydrogen will be reflecting this hydrogen. So basically there is a plane of symmetry for this molecule. And when you have a plane of symmetry for the molecule, you say the molecule is a chiral. Okay. So this is okay. And then moving on to the next question, that is, here you have this cyclohexane. Cyclohexane, it is attached to bromine. Okay. And then Mg, dry ether. Basically this reaction, there is an alkyl halide. Okay, basically this is an alkyl halide, right? Alkyl halide, and when you treat with magnesium in presence of dry ether, what you get is a Grignard reagent. And actually Grignard reagent is a very important reagent. You can use it to perform various reactions. So this is actually an important reaction. We will be discussing it, you will be learning it in the next chapters. Okay, so here what you get is this cyclohexyl bromide, right? Cyclohexane is attached to bromine. Okay, magnesium, dry ether, what you get is to the cyclohexyl you will have MgBr attached to it. Okay, so we can write the reaction as okay, so cyclohexyl to it, here Mg will come, okay, MgBr, okay, and then water. When you react, this is basically Grignard reagent, okay, this is what you call Grignard reagent, and when you treat it with water, what happens is that this MgBr will be replaced with hydrogen, okay. Don't have to write the hydrogen, but basically to make you understand, I wrote this hydrogen. So basically this MgBr will be replaced with hydrogen, okay. So the product that you get here is cyclohexane, okay. So here basically cyclohexyl bromide reacts with Mg magnesium, depends of dry ether to give this Grignard reagent. So here you have Mg incorporated in between, and then when you treat it with water, what happens is this MgBr removed and you get hydrogen over there. So you get cyclohexane, okay. And the next reaction, okay, this is also a reaction to give this Grignard reagent. This is a Grignard reagent, okay. And here you don't have R, okay. So here from this reaction you can see that this is D, right. So here when it was water, you got hydrogen. So when it is deuterium, basically deuterium isotope, right. So here you get D. So basically here what would be the reaction? Basically it will be like CH3, CH, CH3 and then MgBr, okay. And then what will be R? CH3, CH, CH3Br. So from the previous thing you can identify it. So it will be like, so from this you can understand that this will be same, that is CH3, CH2, CH3, okay. Okay, and this one was replaced with deuterium. So below what would be Mg and Br. Okay, and then what is RBr? RBr is basically CH3, CH, CH3 and Br, okay. Okay, so here RBr, CH3, CH, CH3Br, okay. So basically this is R, CH3, CH, CH3. When it reacts with magnesium, what you get is this Grignard reagent, okay. And then this MgBr is replaced with deuterium when you treat it with D2, okay. So that's it. I hope this is clear.